So welcome to our Tejano virtual event. We have a great presentation for you today. We have Mr. Daniel Martinez, who's going to be sharing information about the Makerspace Lab today. And for attending today's workshop, you're going to have the opportunity to earn Tejano passport points. So during the workshop, you're going to see that I'll place the code in the chat so that you'll be able to get those points for attending. And I'll give you some more information about this after the workshop. So please get comfortable, mute your mics, and if you have any questions, you can raise your hand or place your questions in the chat box. And again, I'll be putting that link to the chat towards the end of the presentation. So Mr. Martinez, whenever you're ready, you can begin.
All right, so hello everybody. I'm Daniel Martinez. I'm the coordinator for the Makerspace at Via Verde campus. We're located in Building A, room 1512. So at any point, if you have any more questions about this presentation, feel free to drop by. So yeah, I'm going to give a brief overview about 3D printing and specifically more about the technology, and then I'll go into the specifics about 3D printing in the Makerspace at EPCC. Yeah, well, I'm going to go over 3D printing, types of the different types of 3D printers, materials, slicers, and then us here. So 3D printing is essentially a way to create a physical object from a digital file. Much like regular printing uses a camera to take a 2D picture, 3D printing gets a 3D file format and converts that into a physical object out of a different material. There's two main ways to accomplish this, called FDM and SLA. FDM stands for Fused Deposition Manufacturing, and SLA is for stereolithography, and we'll go a little more into that. So the way we really do this is the computer needs a way to be able to manufacture a three-dimensional object. So with FDM, you take in a plastic spool and it is melted by a hot end. That is like the tip of this machine right here that you can see in this little demonstration. What it will do is heat it to a specific temperature, and that'll cause it to flow. There is a little gear that pushes the plastic through, and that hot end is on top of a carriage that is attached to several motors that are all controlled by a computer that executes commands that you program. Now, obviously, you're not going to program everything by hand. There's a lot of software that will automate this process for you, and so it's not too it sounds more complicated than it actually is. There's also SLA, which instead of using melting plastic, this actually cures resin in a vat. So in this little photo, you can see, imagine that this green background is all liquid resin that cures when exposed to UV light. And this laser would obviously be a UV laser. This isn't exactly accurate because in a real resin printer, we no longer bounce a laser back and forth. We create a mask, which is basically just an outline that we can control. Like imagine a phone screen that you can turn on and off the pixels to be able to draw an image, and a giant UV bulb flashes the entire layer and cures it all in one go. And so we actually have just gotten confirmation that we're getting an SLA printer in the Makerspace. We have the shipping code, the tracking number, and all that. So hopefully that'll be here like next week. And so you guys will probably be some of the first to be get your hands on this technology. The difference between the two of them is that FDM is kind of a lower resolution, lower cleanup and effort kind of technology. So it's really only meant to be made for prototyping and things of that nature. You can obviously make final products, but it's very time intensive. SLA works much faster because you cure an entire layer in one go, but it has the added work of having to clean up because everything is covered in solvents and resins, and you have to wash all of your parts after they come out. And the college has to send the waste to be processed somewhere else. So That's the trade-off. You get higher quality, but more work is required to run SLA. So let's talk a little bit about the materials. Generally, the filaments, the most common ones are PLA, PCTG, and TPU. They all have their various trade-offs, and mind you, there's many, many more plastics than these, but these are the most common that you're going to run into. PLA is polylactic acid, and if you hear, lactic acid and it rings a bell, because it's, it's a bioproduct, and so it's a waste byproduct from like industrial farming, and so it's relatively cheap, pretty easy to get access, technically biodegradable, but realistically you would need an industrial composter to get it to biodegrade properly. So, but it's generally like a good all-around first filament that basically 99% of people will run into. Very affordable, good strength, lots of colors. You're going to get your most options with this. PCTG is a little more advanced of a plastic. So PET, PET is the same plastic that is in soda bottles. So it's like you already have an idea that it's like kind of a shiny, glassy, um, a glassy kind of plastic. Whereas PLA is more of a matte, kind of like rougher plastic. And the advantage of PCTG is that it's recyclable. It has, it's a lot more flexible. So when you try to break it, PLA will shatter, kind of like glass, and PCTG will deform and warp like let's say copper, how there's a lot of yield before it will actually snap. And then there's TPU, which is the interesting one, where it is a soft plastic. PLA and PCTG are all very rigid. TPU has a lot of flex built into it, and so it's good for things that are made out of rubber, things that are going to be compliant, or things that if you're going to touch or interact with, like that you don't want to be a hard plastic. However, it is extremely difficult to print. The TPU, because it's so flexible, it really adheres aggressively to the print surface of the printers, and it can be very, very difficult to remove without damaging the printers. So we kind of try to restrict the use of it. You need special plates to be able to handle it, and but we do still have some available upon request. SLA, so this is all liquid resins, where it's something that you just pour into a vat, and because of that, it's going to have different properties. You're going to have to really like fight to get clear resin, because if it's too clear, the UV light will cure everything, and so it has to be opaque to UV light but clear to like the rest of the visible spectrum. So there's some chemistry that goes in on that. There's a lot of different types of them. Some of them need to be washed, are only able to be washed in isopropyl alcohol. Some of them are able to be washed in water. We have some of those. And there's ones that also have that TPU-like flexible quality. So I've talked a lot about the tech behind this, but I haven't actually gone into like the process. So for you guys, don't worry too much about like the knowing everything. It's actually incredibly easy to get started. Most 3D models, you don't have to know how to 3D model to be able to 3D print something. There's a list of QR codes over here that are links to online libraries that essentially people just throw out their models and you can go ahead and download most of them for free. They're ordered by ease of access. So the top 3 you can just download straight from the website. The next 3 you can download a few and then they make you register. And then the last few you have to pay for these ones, some of these ones. And so try out Printables, Thingiverse things first, and just type in anything that you want to get, and we can probably you can find that file and bring it in, and we can show you how to slice it. So yeah, so you find a 3D model, and then you have to slice it. So imagine the 3D model is your like picture, and then you have to convert it into code that the 3D printer can accept. So there's this software called slicers that take your design and convert it into G code, and it allows you to pick all of the settings. And I'll show that in a little bit. Uh, as for actually, I'll show that right now. So I'm going to go ahead and open up a new window. Let me switch over to that one. One moment. And then share. Application window, Bruce's slicer. Okay, so can you guys see this slicer, Bruce's slicer?
Yes.
Okay, awesome. So this is a slicer. Essentially, this is a really nice one called Prusa Slicer, which has a lot of the uh, it's one of the most used ones. We can go over here to the printables tab, and you can also just find this on the internet. You don't have to download the software to use this. And we'll download a 3D Benchy. So this is one of the most famous ones. It's a boat that's a benchmark for 3D printers. So we would go over here. We would see our model, so you can get an idea for what you are printing out, and you would go over to Files. And from here, you can download the model files, and it's called an .stl for stereolithography. And you go ahead and download. Oh, or you can hit slice if you're already in the software to bring it back over to the platter. So you can accomplish the same thing by clicking this plus icon, and you would just upload an STL file, and it would be the exact same thing. So then we can zoom in here, and you can see your model on the plate. There's a few controls on the side over here, M to move, and you can just place it wherever on the plate. You can also grab it and scale it up by hitting the S key, and you can change the dimensions of your actual model. And you'll notice how over here, when you go over to the size, it'll give you the exact size of what you have in millimeters. So like, let's say we want it exactly 100 millimeters in the Z direction, which is the height. So if you look over here, you have your origin, and you'll have your X, Y, and Z. Z is the blue one, X is the red one, and Y is the green one. And so that's gives you an idea for the coordinate system. Other than scaling, you can rotate it, same as everything else. So this if you move your mouse close to these points, it'll click into place at exact increments, or you can move it outside to rotate it to whatever angle you want. Then you can also place it automatically on a face. So one of the things to note with 3D printing is that you want to have good contact with the base plate right here, the print bed. So if I place it like this, when we go to print it, you're going to get very, very poor contact with this line and this line. And then this will be the base that all the weights and all of the printer movements are like lever on, you know? So it'll be a lot of force on very little surface area, and this will probably break off and fail. We want to look for a nice flat surface that will support the model completely. And so that's why you have this. Most 3D prints have the bottom chopped completely flat. If it doesn't have the bottom chopped completely flat, you can also cut the part in half into a flat plane. And so let's say I was at this skewed angle, but I really wanted it at this skewed angle. I could go ahead and cut a flat plane on it. You can lift it up or down, or you can just write in a value. So let's say I want to be 20 millimeters from the surface, and I want to get rid of object B. So it'll cut it into object A and object B, and we'll just say perform cut. And now we have a nice flat surface that will properly that'll have more surface area to support our print. And this probably would work just fine. There's also the issues with overhangs. So if you are, imagine you're printing this layer by layer. This part over here, when you're printing this, is going to be floating in the air. There's not going to be any way for you to print this without it falling off the part. And so what you can do is go over here to the paint on supports, and you can draw a place where you want the print supported. And so I'll show you really quick. You have to edit the settings to allow where support material, and then turn this on to generate support material, and turn this off to only use the ones that you paint on. Otherwise, the computer will give you an automatic algorithm that sometimes covers way too much. So when we hit the button Slice Now, that's when we actually convert the 3D model into G code, which is what the machine accepts. And so now you can see there's a lot more detail in the model, where each one of these lines is the layer line that the printer, the actual resolution of the printer. And this little green thing is the support that I asked it to put on there. If we scroll down through this timeline, you'll see every single layer that it's going to do one after the other. And so this gives you an idea of any spots where you might have like voids, voids or overhangs or weird geometry. And so you get like an X-ray vision through the 3D print. Over on this side, you can, let's say you're in the middle of something, you can scroll this second scroll bar to see the exact movements of the machine as it makes the part, and the actual code that gets sent to the machine. So G code is actually incredibly easy to read. G code stands for geometry code, and it's just a series of coordinates with a command. So G1 is move to X 133, and that's millimeters, and Y 103. And then E is extrude, which is move the motor that pushes the material out, 0.66. So it's a specific value for how much the plastic should be shoved through the hot end. Regardless, I'm getting like really into the details and the complexity. For most people, you can just delete this, go over to Prusa Connect principles, click slice, and then just use a preset. So you have different settings that are already calculated to be generally good, and you just hit slice now. And for 90% of prints, this will be good enough. And you can go through and see that there's like nothing crazy. Anything that is like at risk of falling is going to be painted dark blue, but this is all like very small things. You see a lot of blue, then it's probably an issue, but this is small and it's tight and it's close to the actual model body, so it's just going to sag a little bit, but it'll be fine. Then you hit send to connect, and that will it opens up a new dialog window, which will show you once you're registered into our Makerspace, it'll show you the printers we have available here. I can just share a screenshot in the chat that, let's see. Whoops. Okay, it won't let me share a screenshot, but it'll just show you which printer is available. And you can essentially just add your print to the queue, and we automatically remove prints as they come in and just put them off to the shelf. Now, one thing to note, we will be charging very soon for prints. We are in the process of getting the account set up for the Makerspace. So for the time being, come in and like try to get a free 3D print before we have that set up. But we'll try to keep it pretty reasonable, where it's not going to be too expensive to do all this. We just need a way to cover the cost of the materials. One of the things that's really nice here is that you get an idea for what each operation, how long each operation takes. So you see the stuff in white stuff in yellow is called perimeters, and they take 18% of our time, and that comes out to 5 minutes. And so you can sit here and optimize your like print settings to speed up your designs if you really want to optimize, but realistically, you don't have to worry too much about this. What is really nice is that at the end of it, you do get a total, which estimated time, which this would take 27 minutes, which is not that long of a time to wait. Over here too, you can see how much filament is actually used in terms of grams and the actual cost. So to print out this boat in raw material, it would cost us 44 cents, which is not too bad. Yeah, does anyone have any questions about 3D printing in the Makerspace up to this point? Okay, well then we'll just move on to the filaments. When you come over here to the settings, you'll notice you'll have the printer settings, the filament, and then the printer. So we currently only have MK4Ss, and so you would just click this preset, and we would set this up for you when you would come in. Eventually, we will move over to Core 1s, and you'll notice how when I update it to Core 1, the size of the print bed changes, and like the location, everything. And I'm pretty sure if we slice it with different settings, let me change the. So one of the things you'll notice is that they have different nozzle sizes. So this is a 0.6 millimeter nozzle size, and this is a 0.4, the new machines that are coming in. 0.4 is a smaller hole, so it's finer, and it's able to capture more detail, but that also means it takes more time. It still takes about the same amount of material, so the cost doesn't change, but the time does increase. So you have different settings. Fast detail will, when you hit slice, you'll see that the layer lines are very, very tiny, and this will take 1 hour and 44 minutes. Now, without changing anything other than the layer height, if we change it to 0.28 draft, instead of 1 hour and 44, we get 35 minutes. So the presets, the lower the resolution, the faster it goes. It makes a world of difference when you're trying to get something done quickly. Obviously, you'll have thicker layer lines, so it'll show off more. It'll be lower quality, but it's a trade-off. Yeah, and then we get over here to filaments. If you go into the configuration wizard, oh, it doesn't show up. Okay, there's a lot of preset filaments. We do calibrations for our own, so we'll give you presets, but it's just clicking this drop down and saying, okay, I want to use the Makerspace preset that we would install for you. There's also a really nice mobile app that you would be able to access this from and be able to upload things directly to our queue from wherever you're at. So yeah, that is just about it for 3D printing. Again, if you have any questions or need any support with this, please just drop by. Our hours are 8 to 5, Monday through Friday, and we're open till 7 on Tuesdays and Thursdays. So really, we're here to help. drop by and we'll make sure you walk out the door with a 3D print, in less than like 30 minutes. Yeah, that's just about it for my presentation.
So I have a question, Daniel. So I'm a student, let's just say, and I go over there because I want to learn how to do a 3D print. So you'll help me use the software to print something that maybe I'm interested in, or that, just to learn how to do it. Is it part of being a student, or is there a cost involved?
So the training is completely free. We don't charge at all for training. You just drop in, and we have staff here that'll show you how to get the software running and make sure that you're able to walk out with something. And so for your prints that you're doing while you're training, we don't charge at all for that.
Okay.
Uh, yes. And again, we encourage people to come in and do personal projects. It doesn't have to be something related to class. Some classes ask that you come in and use the space. Uh, but you're more than welcome to build something for fun. We got a lot of people during Halloween coming in and doing cosplays and things of that nature.
Oh, great. Okay, so you don't necessarily need an appointment, or should you call and find out?
No. Just show up. We're literally just drop in. Don't no need to set anything up. Show like even if you're just curious, just drop in. Somebody will be here to attend to help you. We have people just drop in, like full classes will show up every once in a while. Professors showing people around like the wood shop. And yeah, that's the other thing I really want to get into is that the makerspace is not only 3D printing. Let me share my screen again. The Makerspace has a lot of other offerings. We have laser cutting and CNC milling and sewing and embroidery. So you can bring in a t-shirt and get something embroidered straight onto it. Like you can walk out with that in, again, like 30 minutes. You just have to have an image, and we teach you how to do that. Wood shop. We have like a Cricut vinyl cutter. We have our embroidery machine can only do 4 inches by 4 inches, just so you're aware. But yeah, yeah, Isabel.
Hi, Daniel. You mentioned that everything is free for the students. What about the staff?
Yes, as well. So the just to clarify, the all of the training is free. It's the materials. So it's like we're not gonna be able to provide T-shirts for you if you want to embroider. Like you would have to bring in your own T-shirt. And we do charge for the 3D prints. Or we are going to start charging for the just the material. So like that benchy, which would have been like 50 cents, we would charge that 50 cents, same as the ISC charges for their prints. We just charge for the material. You're more than welcome to bring in your own material too, and just use our machines for free.
Thank you.
But yes, faculty, staff, everybody is more than welcome to drop by. If the eventual plan is to open up the makerspace to the public and have that community outreach. And so we're more than happy to take on people who aren't even directly tied to EPCC, because we cover the cost of our material by people paying for it. And so it's not really like a burden on us to have more people come on. In fact, we want more people, and we plan on hosting more events. So if you guys get the community alerts, the emails, the every first and third Wednesday of the month, like going forward, we're going to have workshops. There was an announcement for one this week, which was a wood shop one, which we did and got a few people in, like a whole class. And I believe the next one is on the 19th. So look out for that one. There'll be emails sent out. And it'll be on my EPCC and the social media.
Great. Thank you, Daniel. Is there any other questions? So there's a lot to offer. I didn't realize how many things you all offer at the Makerspace. This is really nice. So if you all are interested, there's Vallaverde Building A in room 1512. He has his hours up there. So make sure you go and check it out and see if you can learn how to do something new.
Yeah. Well,
Right.
thanks for having me.
Yeah, of course. So thank you, Daniel, again for a great presentation. And I also like to thank all of you all for coming. Join us next Friday. We're going to have a presentation on PREE. That's PREE H2O program, preparing researchers, extensionists, and educators for water sustainability. And don't forget, I put in the chat box the Tejano passport points. So you'll see a link in there that starts with the word apps, apps.epcc. You're going to click on that and you're going to sign in, and it will give you credit for attending today, as well as any other Tejano passport point workshop, or some of the museums around town have a code. So you can get points, and then after you get so many points, you'll earn a medallion that you can wear when you graduate. So join us here again next Friday for our pre-H2O program, and I hope you all have a great weekend. Take care.